Hello everyone and welcome back. I am Mr. Cobalt and in this video we're going to go over Avogadro's law and where it comes from and how it relates to the particles in a gas. So again, we're going to have to relate this to our pressure and our volume and force equation. So if we're going back to understanding how this works with particles, so to understand the properties of gas, we have to understand what's going on at the molecular level. So let's think about this in terms of volume and amount. And so let's think about what happens when we pump up our bicycle tire. So if we have a flat tire, or if the pressure in your car tires is low, or the basketball won't, you can't dribble it very well because there's not a lot of pressure. It's kind of flat. So what do? You put more air into it, right? So just from our daily experiences, we know that if we increase the amount of the gas or the air in the tire or in the ball or whatever, we know that pressure goes up. But why? What's going on at the molecular level? So I kind of said this in an earlier video, but let's go over this again. So if we're keeping the pressure the same, right? Well, let's step back a little bit. So let's go here and we'll see. Okay, so if we're keeping temperature the same, so we're assuming that there's no temperature change. So if the temperature stays the same, then the speed of the molecule stays the same, and that's not going to affect that's not going to affect the pressure or the volume. But let's think about the amount of gas. So if we're putting more gas particles into our container, right? Then what do we expect that's going to happen as we put more particles in there? So we know that the particles are hitting up against the walls of the container. So if we have a certain number of particles, then at any one moment, if you take a snapshot of the particles inside your container, then you'll see that there is some number of the particles that are hitting up against the sides of the container at that very moment, right? And so if you think about all of the forces that those particles are applying together on the sides of the container, that is going to determine the pressure, right? Not only, and and of course the surface area, right? So if thinking about the forces of the particles and the number of particles that are hitting up against the sides of the container at one moment, what do you think is going to happen if I, like, say, put more particles into the container? So I have, like, let's say I double the number of particles in the container. What is that going to do with regard to how many particles I will have pushing up on the container at any one moment? So if I was to double the number of particles in my container, and then I take a snapshot at a moment, am I going to have more particles pushing up against the container or less? Or is it going to be the same? It's going to be more, right? Because I have more particles in there, so at any one moment, I'm going to have more particles pushing up against the sides of the container. And if that's the case, then the pressure is going to increase, right? Now think about it in terms of a container that can change its volume, like a balloon, for example, right? So, and we kind of notice this with, when we're pumping up a basketball. If it's flat, you start putting more particles into it. What happens to the volume? It goes up. Why? Because the pressure is starting to build. So same thing with a balloon, right? You blow into the balloon, you're putting more air particles in the balloon. What happens to the volume of the balloon? It gets larger. Why? Because the pressure is building up and it's making the sides of the balloon stretch, right? So that's how we understand the relationship between volume and the amount of gas you're putting into a container. So if we kind of express this as we did before, then you can see that the more gas we put in, the larger the volume. So it's a direct relationship. So we can write that as volume, right? Or we can do it this way: the amount of the gas, so in moles. So moles of the gas is going to be proportional to the volume, right? And again, if we make this an equality, then if I can multiply this by some constant, I can make that into an equality, whatever that is. So the moles of a gas would be equal to the volume multiplied by some constant. And again, if we divide by volume, then we can get the constant by itself. And then if we can represent the number of moles by N. So instead of writing moles, I can put N over V is equal to K. And so now we're kind of back in the situation of Charles' law where we have the direct relationship. So once again, if I double the number of moles, to keep K constant, I need to double the volume so that that cancels out and stays the same. So if I start with a certain number of moles, let's call that N1, and if I start with a certain volume and then the ratio of those two equals the constant K, then if I change the number of moles or if I change the volume, then the other factor has to change to keep K the same. So if I change N to N2, then the volume is going to have to change as well to keep K the same. And so that's going to be equal to K as well. And as we said before, if two things are equal to the same thing, then they have to be equal to each other. And that is Avogadro's law. So I can write it as, it doesn't matter which side is on top. So I can write it as V1 over N1 is equal to V2 over N2. So you'll notice I flipped it, but again, it doesn't matter which one is on top as long as they're both on the top. So V1 over N1 equals V2 over N2, or you could flip it, N1 over V1 equals N2 over V2. It's still the same law. I put it in this form for a reason, and you'll see that later. But this is Avogadro's law, and we can understand, again, Avogadro's law by going back to what's going on at the molecular level and looking at what's going on with regard to force, volume, and surface area and pressure. I hope this was interesting and helpful. Thank you for joining me. If you like this video, please share it with others, subscribe to the channel, and make a comment in the comment section, please. And let me know what you think, and hit the notification bell so that way you can get more videos from me as they come out. Thanks for joining me, and have a good night. See you next time.